Okay, I'm going to follow the instructions here that it tells us to do. And first we assembled the test circuit that I just showed you, and it says to get an oscilloscope probe and connect it to channel 1, or the A input on the oscilloscope. So that's this thing here. This is our oscilloscope probe. This is the end of the probe that we connect up to whatever it is we're going to measure. And the tip is what we actually connect. And this little wire coming off, that's the ground clip, which you often need to connect to the negative or ground of the circuits you're testing. And this is what you actually clip onto. And you pull a little sheath back on there, and it will let you clip it to whatever you want to measure. So we're going to plug that into our oscilloscope, and that goes right here. There's two inputs on this oscilloscope. It's a dual channel oscilloscope, so it means you can measure two different things at once. We're going to measure one thing here, so we'll just plug it in on the first channel, which is called channel 1. And that's what we're plugged into. Then it tells us to, of course, turn on the oscilloscope, which I've already done, and it says to set it for internal trigger operation. So on this particular oscilloscope, it does have a trigger system on it. Most oscilloscopes do, and the reason for a trigger is, you see, what an oscilloscope does is it draws a picture on the screen with a electron beam, and you can see the line that's being made by that electron beam, but what you can't see is that the electron beam is moving across the screen very fast. So if I slow that down, you can see that dot going across the screen there. That is the tip of the electronic pencil, if you will, or the electronic pen that's writing on the screen. And when I speed it up, it moves across so fast that it forms a line, and that's what our eye sees. It looks like a line. And right now there's no signal going into the oscilloscope, so it's just a straight line. I can move the position of that line up and down using the position control knob here. That lets me move it up or down to centered or whatever I want to do on that channel. Okay, another thing it asks us to do is it says to set it to AC input. There's a switch right here, and you can see on that switch it says AC, or it says DC, or it says ground. Now what that does is, if we're going to look at alternating current, we want to set it to AC, and that's what we're going to look at today. So we'll connect it to AC, right?
Right.
Okay, and then the next thing it tells us is, it says a trace line should appear, and we can move it to the center of the screen using the vertical and horizontal position control knobs. Well, I was using the vertical knob here. That moves it up and down. And there's also a horizontal control knob over here, and that moves it sideways. In other words, if the line isn't centered on the screen, you can move it sideways with that. And then it tells us here that we want to adjust the trace line focus and intensity. So what's that? Well, you got a control here for brightness or intensity. So you can turn it up bright or dim. That's that one right there. It says intensity. And then there's also one for focus. And what focus does, if you have it out of focus, well, it's just all blurry. So you want a nice sharp line so you can look at. So you just adjust that so it gets a nice sharp line like that. Okay. And then it says to set the time per division control for about 1 millisecond. So what's that? Well, that's over here. What that control does is time per division controls how long it takes the dot to move across the screen. And specifically what it does is it tells how long it takes the dot to move across one of these divisions, or little squares on the screen there. Each one of these little squares represents a certain amount of time. So you can see if I turn it really slow, you see it takes a certain amount of time. Like right now, I have it set to 0.1 over here. It's set on 0.1 second per division. Well, 0.1 second per division, that means the time it takes for it to go across one of those divisions or squares on the screen. And the instructions here tell us to set it to 1 millisecond. So I'm going to set this control to 1 millisecond. All right, well now it's moving across the screen fast and we can't see it. It takes only 1 millisecond, a thousandth of a second, to move across one square. So that's moving pretty fast. We can't see it now. The instructions also say to set the volts per division control to 0.5 seconds. I'm sorry, 0.5 volts. 0.5 volts. Right, so that's this one here, volts per division control. I want to set that to 0.5. Well, I guess we have that already on there. And what does that control? Well, that controls the up and down part of the scope. We watched a video in class where he talked about the up and down part. That's what this part is right here. This is the up and down part, and this is the sideways. This would be the vertical or up and down part, and this would be the horizontal or the sideways part, and that involves time because it takes a certain amount of time for the dot to move across the screen. The up and down part has to do with voltage because it's the voltage that makes the up and down part move up and down on the screen. Okay, now in fact, what is an oscilloscope? It's really just a voltmeter that draws a graph for us. That's really what it is. In fact, I can show you that. Here we have our breadboard here, and I'm going to hook up the oscilloscope and measure the voltage using the oscilloscope. In order to do that, since I'm going to be measuring DC, I do need to switch this switch back to DC for a moment. So I'm going to switch it back to DC. And now I'm going to take a couple wires here, just real quick. A couple wires handy there. My assistant is getting for me. So I'm going to put one wire on the ground, or negative, down at the bottom. And I'll take the other one and kind of connect it up to the top up here. I'll put it on the 6 volts. So I'm going to use my oscilloscope then to measure that. I'm going to connect the end of my probe tip to the 6 volts, and the other I'll connect to ground, like that. So I've got my oscilloscope hooked up to, all I have it hooked up to is just the batteries inside the breadboard. Now, to read that on the oscilloscope, I need to, of course, turn on my breadboard, and I'm going to disconnect the speaker so I don't have to listen to that beeping sound all the time there. But what I'm going to do now, right now I'm going to set this, I'm going to disconnect the probe here for a moment, and right now that's 0. So I'm going to move the line down on the screen to the bottom here, right to the bottom line, like that. See, I moved it down to the bottom. Now, when I connect my probe back to the oscilloscope, it made the line jump up. You notice it jumped off the screen completely. I don't even see it. That's because I have it set to 0.5 volts per division, half a volt per division. So it's actually set too low. I need to set it to a higher volts per division. There, I set it to 1 volt per division. So what it did is now it's jumping up 1, 2, 3, 4, 5, 6.5. 6.5. So you see, I'm using it like a voltmeter in this case. But of course, that's not what you could just use your handheld voltmeter to do the same thing. But there it is, it's acting as a voltmeter. If I flip it back to 0, there's a switch here. You notice it says ground on it there? If I flip this input switch to ground, what that does is it connects the input to 0 volts, which is ground. You see how the line goes back down to 0 there?
Yes.
So here, and then if I flip it back to DC, then it goes up to the 6.5 volt mark there. So that's 1, 2, 3, 4, 5, 6, and about 6.5 volts. So that's how those lines tell us about voltage. Okay, now let's go back to our instructions here, and it says to set the vertical and horizontal sweep control knobs to calibrate the detemp position where it clicks. These knobs are mostly found inside the volts per division and time for division control. So what we're talking about there is there's these knobs right here. These knobs are for calibration, and we normally want to have these where they click. So those are set where they click. Also, in a lot of oscilloscopes, they'll have a knob inside the timbre division the same way. This one doesn't have it inside there. It's actually over here, but it's the same thing. You set it where it clicks, right there, where it says, see where it says calibrate? So what we want our oscilloscope to measure correctly. We want it to be calibrated. That's all that's doing. We just want to make sure that it's set to calibrated setting. So this is set to calibrate. See how it says down there is calibrate? And there it says calibrate. Pull this out so you can see it a little better. Yeah. So that's set on calibrate. That's important because otherwise our measurements won't be accurate. They were already set on calibrate, so we were okay as far as our last measurement. Okay. I'm going to stop for a second here.